Okay, this is quite an interesting question here. So the sum between k equals 0 and infinity of minus half to the power of k cos of k theta. Okay, so let's just expand this series to see what it actually is. So let's put k equals 0, 1, 2 and 3, etc. So we have k equals 0, and we have minus half to the power of 0. Oops, sorry, 0 cos of 0 theta, and then putting k equals 1, we have minus a half to the power of 1 cos of theta. Putting k equals 2, we have minus a half squared cos of 2 theta. Putting k equals 3, we have minus a half cubed cos of 3 theta, and etc, etc, which equals, expanding everything out, well, minus half to the 0 is 1, and cos of 0 is 1, so that's 1 minus a half cos theta, add a quarter cos 2 theta, minus an eighth cos 3 theta, etc, etc, etc. So this is what we are being asked to sum to infinity. Okay, so what we need to do is we need to look at the series 1 minus a half e to the I theta, add a quarter e to the I 2 theta, minus an eighth e to the I 3 theta, etc, etc, etc. Now this is a geometric series where we have a equals 1, which is the first term, and the ratio is minus a half e to the I theta. We can see here that this is minus half e to the I theta, and this is minus half e to the I theta squared, and this is minus half e to the I theta cubed, and that is a geometric progression, and we know that the sum to infinity of a geometric progression is equal to a over 1 minus r. So plugging in our values, we have that the sum of this series here is equal to a, which is 1 over 1 minus a half e to the I theta, which, multiplying everything by 2, gives us 2 over 2 plus e to the I theta. Okay, now that is the sum of this, and in actual fact we want to find the sum of this, which is the real part of that. So the sum of what we actually want is the sum that we actually want, which is equal to 1 minus a half cos theta, add a quarter cos 2 theta, etc, 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 is the real part of this sum here, which is what we just worked out, 2 over 2 add e to the I theta. Now, finding the real part of this, we need to get I theta on the top. So what we do is we multiply by the conjugate, and the conjugate of 2 plus e to the I theta, this is a common mistake, it is not 2 minus e to the I theta, it is, instead, the conjugate of 2 plus e to the I theta is 2 plus e to the minus I theta. So we want to multiply, let's multiply this, so that's 2 over 2 add e to the I theta, times the conjugate, just to get rid of the e to the I theta from the bottom, is 2 add e to the minus I theta over 2 add e to the minus I theta. And that gives us, just expanding this, that gives us 4 add 2 e to the minus I theta over 4 add 2 e to the I theta, add 2 e to the minus I theta, add e to the I theta times e to the minus I theta is 1, which equals 4 add 2 e to the minus I theta over 5 add 2 brackets e to the I theta add e to the minus I theta. Now, so our sum that we want is the real part of this. All right, so we've still got a little bit of work to do. What is e to the I theta add e to the minus I theta? Well, just from our basic e to the I theta equals cos theta add I sine theta, and e to the minus I theta is cos theta minus I sine theta, then e to the I theta add e to the minus I theta is 2 cos theta, just adding these two together. So we, instead of e to the I theta add e to the minus I theta, we can put 2 cos theta. So now we know that our sum is the real part of 4 plus 2 e to the minus I theta over 5 plus 2 times 2 cos of theta. And so therefore we know that the sum 1 minus a half cos theta add a quarter cos 2 theta add da da da, which, as we've already seen, is the sum between infinity and k equals 0 of minus a half to the k cos of k theta, is the real of this, and writing e to the minus I theta in cos theta plus I sine theta form, that means it's the real of 4 add 2 cos minus I theta add, oh, excuse me, sorry, that's made a bit of a mess of that, that's 2 cos of minus I theta add I sine of minus I theta over 5 add 2 cos theta. Now we know this is real, this bit, and so sorry, there's no I in there, is there? So it's minus theta and minus theta. So we know that the answer, the solution, is the real part of this, which is that, i.e. the sum between k equals 0 and infinity of minus half to the k cos k theta equals 4 add 2 cos theta, because cos of theta is the same as cos of minus theta, divided by 5 plus 4 cos